L-shaped rod. This is a pin jointed over here. That is, it can rotate like this. It can rotate like this. This is 10 meter length and this length is 5 meter. In the middle of this, there's a 10 kg mass is hanging. So that if this force is not then certainly, because it is hinged over here, this will move like this will rotate like this, and this will come down. So that it doesn't come down, a horizontal force F is being applied in this direction. The question is, what is the value of this force so that it doesn't move in this direction? So now, what is the axis rotation you will take? Take the axis rotation where there is maximum confusion. Right now, we have maximum confusion over here. We don't know that is what are the forces which are acting over here. As soon as we choose this axis rotation, the torque of all the forces, whatsoever the direction they may be acting in this direction, this direction, this direction, any direction they may be acting, torque of all those forces, that is going to be equal to 0, because torque is force into perpendicular distance between line of force and axis rotation. And if we choose this as axis rotation, then the perpendicular distance between any line of force and axis rotation, that comes out to be equal to 0. So that is their contribution towards torque about this axis comes out to be equal to 0. So wherever there is a maximum confusion about that axis, take the torque initially. Now, if you have taken this as acceleration, now there are two forces, that is 10 kg, 100 Newton, that is 10 kg and 10, 100 Newton is trying to rotate this way and F is trying to rotate this way. So the torque about, we say, O is going to be equal to 0. So it means this is 100 Newton is trying to rotate this way and F is trying to rotate this way. Clockwise movements is equal to anti-clockwise movements. So it means 100 into 5 is equal to F into, now students most of the time they take this as distance. Please understand, this is not the distance. Torque is force into perpendicular distance between line of force and acceleration. If any confusion, you draw this. This is the line of force. This is the line of force. This goes till infinity. So what is the distance of this line, this river from this axis? This is the distance. What is this distance? This is 5 only. So this is going to be F into 5 only, and F comes out to be 100 Newton. So 100 Newton is the answer, and please see that is torque is force into perpendicular distance between line of force and axis rotation. This is not the distance from the point of application force, but this is the distance between line of force and axis rotation. Now let's say we have to find what is a pin reaction over here. What are the forces which are experienced by this pin or by this rod at this end? So now if we draw the free body diagram of this once F is known, so it is going to be something like, over here that is we have a 100 Newton force. Over here that is we have how much? Once again 100 Newton force only. This is the thing. Let's say we don't know what are the forces which are experienced by this member or this free body over here. We don't know. Let's say it experiences two forces in this direction. We take any x and y direction. Let's say this is Fx and this is, we say this is Fy. The forces which are experienced by this rod at this point, these are forces. Obviously, this body is stationary, that is in translation equilibrium also, it means summation of forces along x-axis is equal to 0. That's why net force along x-axis should be equal to 0. When the net force along x-axis should be equal to 0, that is this side forces should be equal to this side forces. It means Fx, this force along x-axis, that has to balance this 100 Newton. Similarly, so it means Fx is equal to 100 Newton. Similarly, net force along y-axis should be equal to 0 because this rod is not moving along the y-axis, neither going up nor moving down. So downward forces, that is 100 Newton, should be equal to Fy. So Fy should be equal to 100 Newton. So it means over here, this rod is experienced at this point two forces, 100 Newton this way, 100 Newton this way. So if this rod is experiencing 100 Newton this way and 100 Newton this way, can we find what is the net reaction force over here? Then certainly it is. So it is going to be in this direction at an angle of 45 degree, and this is going to be under root of 100 square plus 100 square. This is going to be this thing, that is 100 root 2 Newton in this direction. And what way the pin will be, this pin which has been inserted, to have reaction there is equal to opposite reaction. So this pin is applying a force in this direction, so this pin will experience a force in this direction, what? That is 100 root 2 Newton at an angle of 45 degree. To have reaction there is equal and opposite reaction. So this way we can find the net reaction at this point also. So first of all, take the axis for the torques where there is maximum confusion. you find the value of F. Once you have found the value of F, then over there in any arbitrary x and y axis, take the force. It is not necessary you have to take the force this way. You can take the force this way also. But this plus this is equal to 0 if you are taken it this way. So this comes out to be, that is minus 100. That is direction it has to be reversed. That is, this force should be in this direction. So any way you can take x and y axis, you can then apply the translational equilibrium. That is net force along x axis is equal to 0, net force along y axis is equal to 0. From there you will find the reactionary force along the x axis also, along the y axis also. Once you know these two forces, then you can find the resultant also and the direction also. Once you find the resultant, this is the force which is experienced by this rod, and this is being applied by the pin in this direction. So pin will be experiencing the force in the opposite direction, because to every reaction there is equal to an opposite reaction, and from there you can find the reactionary force at the pin also.